Okay, so we're just going through some more examples today. So we have, in the first question, we're calculating for the shapes I've given you here, the perimeter and the area. Okay, so in this first shape here, we have a sector. Now, if you look at the sector, it's got an angle here in the middle of 210 degrees. Okay, so we need to work out the fraction of the circle that it's taking up. All right, so the first thing we're doing, you're going to get your red pen and just go around the curved bit. All right, we're always going to start with our most complicated part of the question because it gets that part out of the way. All right, so any curves, we're going to find those first. So we're going to find this arc length. Remember, an arc length is L. So we're going to find L, that red part, by doing theta over 360 degrees to find the fraction of the circle it takes up, times by the circumference of the circle. Because remember, it's part of the circumference of the whole circle. So we have 210 degrees in the middle over 360 degrees times 2 times pi times the radius, which is 24. If you put that into your calculator, that's what you're going to get. Now, we're not going to round anything to one decimal place yet, okay? You don't do any early rounding. Sometimes you're going to end up with the wrong answer if you round now. Okay, so when we then go to find the perimeter, so we're going to write P for perimeter, we're going to write down our full answer we got for this curve, and then we're going to add on this and this to be getting the whole perimeter of that shape. Okay, so it's the whole curved arc length plus 24 plus 24, and you get that answer. Then right at the end you can round to one decimal place. Okay, looking at the area for that same shape, we find area equals the fraction of the circle it takes up times pi r squared, because it's what fraction of the area formula. So we've got 210 degrees out of 360 degrees for the fraction, times pi times the radius, 24 squared. If you use your calculator, then you can round that off because the area is all done in one piece, one working. Okay, we're going on to another shape now. So again, we're going to find the perimeter first. Start with your curve. I'm going to draw a red curve here. That's what we're looking for. Remember, it's called L. So the arc length formula is theta over 360 times 2 pi r, because it's a part of the circumference of the circle. Now, this question's a bit tricky. You need to be putting the angle in that's at the centre of the circle of that sector. Now, this sector is actually a major sector. It's a really big one. This little piece here we would call a minor sector because it's smaller. So we need this angle here. So just get your red pen and mark that angle. So we need that angle, not this bit here. Right, so to find that angle, you're going to do 360 degrees, take away 60, and you'll get 300 degrees. So that's the angle that goes in that spot. So we're going to use 300 degrees for our theta. Put that over 360 times 2 times pi times the radius of 42. Your calculator will give you that answer. But we want the full perimeter, remember, so we're going to do all of that answer, plus this, So plus 42 plus 42, that's what you'll get, and then you round it off to one decimal place. Okay, next one. So over here we're doing the area for that same shape. So our area formula, theta over 360 times pi r squared. Remember, your angle is this one here. We just found it's 300. So that goes in there. Times pi times the radius, 42 squared. And then put it in your calculator and you'll get that answer. And then we're rounding off to one decimal place at the end. Okay, and that will give you a 1 after the decimal point. All right, now in these next questions, we're just finding the perimeter. And you can see the perimeter is the trickier part because you've got to find the arc length and then you've got to add on any other sides you can see. All right, so in this one here, I haven't drawn it real well, but this curve, this one down here, this one down here, and this one down here, just a minute, I should have written right angles in here. Okay, those 4 curves, I want you just to go over them with your red pen. Okay, now those 4 bits, if you took these pieces away from the rest of the shape and then did a jigsaw puzzle and tried to join them together, you would actually form a whole circle. Okay, because you've got a quarter of a circle here, see the little right angle? A quarter of the circle here, a quarter of it here, a quarter of it here, and a quarter of it here. So if you put it all together, it would actually form 1, 2, 3, 4, would form a whole circle. So we're going to find the circumference of one whole circle, and we'll do all those curves together then. So c equals 2 pi r, c equals 2 times pi times, now the radius is this bit here, 7, and then put it in your calculator. No early rounding. Okay, now we're going to find the perimeter. So you want to keep that answer that you just got on your calculator. Don't go and clear it, just keep it there. And you'll be sitting there like that. And then you're going to add on, write it in your working, all the other straight sides. So we've got this one, this one, this one, and this one to add on. Now I told you down here that it was 15 and that they're all equal to each other. So we're adding 15 plus 15 plus 15 plus 15. Here's your answer, and then you can round off to 2 decimal places like they asked. Okay, next question. Now this one, we've got a semicircle that's this piece here. So just get your red pen, go over the semicircle. Always find the curve first because it's the hardest bit. Alright, so that's a semicircle, so it's a half of 2 pi r for your circle circumference. Then we're just putting our radius in, so it's a half times 2 times pi. Here's your radius times 65. Put it in your calculator and you get that answer. Now, to get your perimeter, we're going to start with that. Keep it on your calculator, but write it all down again. I'm going to add on all the straight sides. Now, I'm going to go round the shape this way. So we've got that. Now I'm going to add this bit. Now, what would that piece be? Think about it. That radius there, 65, right, will go all the way around. So I could say that this piece here, from there to there, is 65. Because think of it like the hands of a clock. By the time it moves around, that's 65. If it goes the other direction, this will be 65. So if we've got 65 plus 65, we have 130 here, and that whole thing across there is 150. So what's 150 take away 130? Well, that leaves you with 20. And this looks like it's been split pretty evenly. So we're going to say that this is probably 10, and that means that will be 10 as well. Okay, now if you go, oh, it didn't actually tell us that they were equal, doesn't really matter because we're just adding things up. So as long as these two numbers add to give you 20, it doesn't matter. So if you have 8 and 12, they're still going to add to give us 20 by the time we add everything up. Okay, so we've got a 10 in here. We're going to round the shape, right? The curve plus 10 plus 90 plus 150 plus 90 plus one more 10. And if you add it all up, you'll get what I've written down there, and then round it off to 2 decimal places, and you get 554.20 centimetres. Okay, one more. And this one's a bit tricky. All right, let's have a look at it. So there's a couple of tricky bits in this next question, so just be careful with it. All right, so this shape, we're going to start with what I've called the red line. So I've just gone over that side there, and I've called it the red line in my working so I can see what I'm doing, and the person marking it can see it. So to find the red line, well, if we just move a few things around here, this 8 can be moved to there. So that would be 8, going straight down there. Now, if that's 15 from there to there, and this is 9 from here to here, then that makes this piece here 15 take away 9, which is 6. Okay, so now we've got a little right-angled triangle that we've formed. Here it is. Now if you want to draw it again, you can. I can draw it over here. This is 6. Oops, that's 6, that's 8. So we're using Pythagoras' theorem to find that hypotenuse, which is our red line. Okay, so we're finding C. If you can see the Pythagorean triad in this, great. You will get it very quickly. But if you can't, we're just going to go through and do it like this, and you'll get C equals 10. But it actually was, for those of you that spotted it, it's the 3, 4, 5 triad. Everything times by 2, 6, 8, 10. There's our missing number. I'll just let you see that. Okay, so 3, 4, 5 triad times by 2s, you get 6, 8, 10 for your Pythagorean triad. If you wanted to do it that way, it'll be a lot quicker. But if you don't spot it, that's okay. Just go through this working. All right, now the other difficulty is the semicircle over on this edge. Might just go over it in blue. Helps to have different colours when you're doing a test. So we're doing the blue semicircle. So this time I'm going to use the pi d formula. So pi d can be the circumference of a circle, half of it for the semicircle. So half times pi d. So we've got half times pi times, and you can see I actually have the diameter of that circle already there. So I'm putting the 8 straight in. Now when you put it in your calculator, that's the answer you'll get. Now let's put it all together to get this perimeter. So we have our curve, 12 point whatever. We're going to start here, right? We've done the curve, plus 9, there it is, plus 10 that we got for our red line, plus 15, and you're back to where you started from, so you've got everything there. Add them all up and round off to 2 decimal places. That one's 5 or more, so it'll be going up to a 7. Okay, we're going to come back in the next video and do some more examples.